So today I'm gonna explain Maclaurin series, and I'm gonna write the Maclaurin series for e to the x. Like, dealing with polynomials is really easy. It's easy to integrate, it's easy to differentiate, and it's useful for take approximations in physics, and it's really useful. Let me just explain it. First of all, we need to know the graph of the e to the x, and it would be like something, it looks like this. Right now it intersects at the y-axis at 1, so at this y-axis x coordinate is 0, so I can just write it e to the 0, and that would be equals to 1. So if I wrote a constant function approximation like this, the equation of this is y equals 1. And if I really quickly write the polynomial form, and so on, if I put down x is equals to 0 at this function, I get e to the 0 is equals to c naught plus, and this all other terms would be 0, so 0 plus 0 and so on. So c naught is equals to e to 0, it's nothing but 1, and this is an constant function approximation, let me say. And if I write like this, a linear approximation is nothing but it would have a linear equation, right? So now, to find this linear equation, we need to find the derivative of this. We can write the derivative for this function, that would be e to the x equals, this is a constant, so it will get cancelled, and c1x plus 2c2x and so on. Now if I put 0, e to the 0 is equals to, there's no x right here, so c1, and all other terms would be 0, so c1 equals 1. So c naught is equals to 1, c1 equals to 1. And if I derive another time, and if I find the value of c2, c3, c4, I get something like c naught equals 1 by 0 factorial, which is nothing but 1. We just found it right here. And c1 equals 1 divided by 1 factorial, c2 is 1 by 2 factorial, c3 equals 1 by 3 factorial, and so on. So now we can write that e to the x equals 1 by 0 factorial x to the 0, or nothing but it's just 1, plus 1 by 1 factorial x to the 1 plus 1 by 2 factorial x to the 2, and so on. Or I can just use this notation called sigma, which is the repeated summation. And if I use like something I equals 0 to infinity x to the I divided by I factorial, and this is the polynomialic form of e to the x, and you can easily approximate it. Like, the third term of it will be, or like the fourth term, the first 4 terms of the polynomial would be really approximate to this e to the x, just like this. This is e to the x, and the fourth term's equation would be like this. It's just not approximated right here. And if we wrote infinite terms like that, it would be really approximate, and it would be e to the x.